Hi, my name is Sankar. Today we are going to conduct the Atterberg limit test in order to determine the liquid limit and the plastic limit of a fine grained portion of a given soil type. We are conducting two types of liquid limit test. One is the Casagrande test and the other one is the cone penetrometer test. By definition, the liquid limit is the minimum moisture content at which 25 blows into the Casagrande apparatus will just close a groove cut into a soil. In a more general sense, it would be the moisture content which a soil begin to act less as a viscous fluid and more as a plastic putty. And the plastic the plastic limit is the definition is minimum moisture content at which a soil can be rolled into a 3 mm diameter roll without breaking. In a more general sense, it would be the moisture content at which the soil begin to act less like a plastic putty and more like a brittle solid. So the liquid limit is defined as LL and the plastic limit is noted as PL. You are going to need the plasticity index to classify the soil type according to the unified soil classification system, and that's given by the difference between the liquid limit and the plastic limit. I'll introduce you the equipments we are going to use today. So for the Casagrande test, we are going to use the standard Casagrande apparatus and the grooving tool. We are going to use few metal cans to determine the moisture content and a spatula. For the cone penetrometer test, we have the cone penetrometer as well as the moisture content cans. For the plastic limit test, we have a glass plate here and 3 mm steel rod to compare the rolled soil sample against, and this is our soil sample for plastic limit test. These are the moisture content cans. For all the tests, we are going to determine the moisture content for each sample we are going to test, and for that we are going to need a digital scale as well. So when you do the practical, you will be given a pre-mixed soil sample to determine the liquid limit test, and before you place the soil sample in the Casagrande dish, make sure that you calibrate the Casagrande dish according to the specified height. So this height should be there when you raise the cup using the rotating handle. Place the apparatus inside underneath the cup, and when you rotate the handle, this block here should just touch the cup, otherwise you will have to calibrate accordingly. So you can place the soil sample using the spatula here. Once you place the soil sample in the dish, it should be parallel to the base of the apparatus and not more than 10 mm deep. So once you prepare the sample, clean the dish and cut a groove using the grooving apparatus. Now start rotating the handle about 2 turns per second and record the number of blows you need to close the groove about 13 millimeters. So once the groove closes about 13 millimeters along the groove cut, you record the number of blows in the data sheet number 5 against the sample. Once you complete the test, repeat the test until the number of blows for closure in 2 consecutive tests is not more than 1. And once you complete such tests, you can weigh the metal cans and get a small amount of soil from the sample and use it to measure the moisture content. You can record these values in data sheet number 7. Make sure you write down the can number and the empty can weight. Once you measure the wet soil plus the can weight, you're going to place this in an oven for 24 hours and then take the can out and record the dry soil plus the can weight. You are going to use those values to determine the moisture content of the particular soil sample. You will have 3 different types of soil batches for the liquid limit test. Make sure that you conduct the Cassagrande test on each soil sample and determine the moisture content of the particular soil sample. Once you complete the moisture content calculations, you can plot the blow count versus the moisture content in a semi-logarithmic scale. Make sure the blow count is in logarithmic scale and the moisture content in the natural scale. And when you plot the blow count versus moisture content and draw the best fit curve, the blow count number 25 will give you the liquid limit of the soil sample. So the next test to determine the liquid limit is the corn penetrometer test. This is the corn penetrometer apparatus, and we are going to fill this cylinder using the soil samples we are provided with, and there shouldn't be any voids inside the soil sample. Make sure the cylinder top is leveled and clean the cylinder and place it in the corn penetrometer apparatus. So once you place it here, make sure the tip of the corn penetrometer is at the surface of the soil sample and set the gauge to 0. Once you set the gauge to 0, make sure the soil sample is in the middle of the apparatus and release the corn penetrometer for 5 seconds. And take the reading in the gauge. For this test as well, you're going to use the data sheet number 5. So you have to repeat this test 3 times for each batch. That's 9 corn penetrometer tests. Make sure you take a bit of soil into a small moisture content can and conduct the moisture content calculations. I'll first measure the weight of this cup. Record the value in data sheet number 7. Then take the wet soil plus the container reading and place this can in an oven for 24 hours. So once you complete the corn penetrometer test and have the actual moisture content readings calculated from the oven dried samples, you can plot the penetration versus the moisture content plot. The penetration should be in the log scale, and the moisture content related to 20 millimeter penetration will give you the liquid limit for corn penetrometer test. So now we are going to conduct the plastic limit test. Take a soil sample from the samples given to you for plastic limit test. Get a small piece of soil from the sample, about 10 cubic millimeters, and roll it with your palms and against the glass plate. You can compare whether this is 3 millimeters in diameter with the steel rod given to you, and if this thread crumbles before it reaches 3 millimeters, that means it's too dry. If the soil sample is too wet, it will not crumble when it reaches 3 millimeters. So if it's too wet, make sure you make it dry by changing the moisture content by needing to dry up the moisture in the soil sample. So this soil sample is too wet, so I'm going to dry it up a little bit. Okay, now it starts to crumble when it reaches a diameter of about 3 millimeters. So now it's in the plastic limit. We are going to measure the moisture content of this sample by using a moisture can. So we first record the weight of the empty moisture can, record the value in datasheet number 7, and then with the wet soil in the can. And place this in an oven for 24 hours. So once you get the thread crumbled at 3 millimeter diameter, make sure you repeat it few more times and get the average of the plastic limit for each sample. Okay, so once you complete all 3 tests and you have the moisture content readings, you can get the liquid limit and the plastic limit of the soil sample. Once you complete all the data sheets, data sheet number 5 and data sheet number 7, you can determine the liquid limit and the plastic limit of the soil type, and then from that you can determine the soil classification according to the Unified Soil Classification System, which is given to you as a flow chart. You have to complete those tasks before you leave the lab class. And for the recording of the results assessment criteria as well as the gradation, you can refer to the lab notes. Thank you.